In this video, we're going to talk about transformations of graphs. The general formula for a parabola is g of x equals a times f quantity bx minus h squared plus k. A vertical dilation deals with the a portion of our equation. So if a is greater than 1, we would expand vertically. If a is greater than 0 but less than 1, we would compress vertically. And if a is equal to 1, there's no change from the original parabola. So if this is our original parabola, we would know that a equals 1. So if a is greater than 1, we expand vertically, which looks like this. If a is less than 1 but greater than 0, we compress vertically, which looks like we kind of smushed it towards the x-axis, which will look like this. Horizontal dilation deals with the b part of the equation. If b is greater than 1, then we're going to compress horizontally. If b is greater than 0 but less than 1, we expand horizontally. And if b is equal to 1, we have no change. So if this is our original parabola, we know that b equals 1 and there's no change. If b is greater than 1, then we compress horizontally, which looks like this. If b is greater than 0 but less than 1, we expand horizontally. We compress horizontally for greater than 1. And we are expanding horizontally for 0 is less than b is less than 1. A horizontal transformation occurs with the h portion of the equation. So if h is greater than 0, move h units to the right. If h is less than 0, you move h units to the left. And if h is equal to 0, there's no change. So if this is our original parabola, this would represent h equals 0 because there's no change. If h is greater than 0, we're going to move h units to the right to have the same parabola that is moved h units. Now if h is less than 0, it's the same but in the opposite direction. We've moved h units to the left. Vertical transformation deals with the k portion of the equation. If k is greater than 0, you move up k units. If k is less than 0, you move down k units. When k is equal to 0, there's no change. So our original parabola would be k equals 0. If we move up k units when k is greater than 0, it looks like this, with the distance of k units moved up. K is less than 0, looks like this, with a distance of k units moved downwards. So let's do an example. Let's describe the transformations of g of x equals 2 times the quantity x plus 3 squared minus 2. Let's first start by defining our parts of the equation we've talked about, a, b, h, and k. So our a in this case is the number out front, which is 2. B is the number that's in front of the x, and we don't have any number there, but we have that 1. That is the placeholder there. The h is the part that is the x minus h. So we have x plus 3, which means that h has to be negative 3, because x minus a negative 3 would give us a positive 3. And finally, the k is the portion out in the back, which is a minus 2. So an a equal to 2, that means a is greater than 1, so we're going to expand vertically. b equals 1 means no change horizontally for the dilation. A negative 3 for the horizontal transformation, so h is less than 0, we're going to move 3 units to the left. And a k of negative 2, which is k is less than 0, we're going to move down 2 units. So if we first draw our original parabola, which looks like this, we can now apply the transformation and see what our new parabola will look like. So we know we can move the vertex left 3, and down 2. So this is our new vertex. And so we're going to expand vertically, so it's going to crunch our graph towards the y-axis, so towards that middle line of symmetry. So a -1 gives us a +6, and a -5 also gives us a +6. So we get a parabola that looks like this. So you can see that it's moved over 3 units to the left and down 2 units. And it's also slightly more expanded vertically.